Okay, so if you're here watching this video, probably one of two things. Maybe you're struggling with in class, or maybe this is your first time ever and you need to really get an idea of what's going on. Either way, the first thing that I'm going to do in this video is I'm going to go over some core concepts. If you don't want to see those core concepts, check down below in the link in the description box. And in the description box, I will put the times at which you can just skip directly to the time in which I just do problems. Okay, so but if you want to watch the core concepts piece and the introductory piece, then here we go. So core concepts in solving one-step and two-step equations. And I'm not doing anything with variables on both sides. That will come in a later video. Are going to be three main things, and the three main things are the inverse property of addition, reciprocals and what they are, and then the inverse property of multiplication. So here we go. So the inverse property of addition states a very simple thing. Okay, if you take any number, we'll just say a, all right, for any number, so a variable represented can be anything, and add to it the opposite of that number, then you're always going to get 0. And that means basically that any number, okay, added to its opposite, okay, will equal 0. So just to show a quick little example of this, that if you took 5, okay, and added, all right, -5, the outcome would be 0, because 5 and -5 are opposites. So reciprocals. Given a number, and we'll say a, okay, its reciprocal is 1 over a. So we'll deal with this a little bit later. Basically, a couple things you need to know is how you do this if I have a fraction. So we'll deal with that a little bit later. Inverse property of multiplication. So the two things above are reciprocals. So basically what I'm saying to you is that if you take a and multiply it by that reciprocal, okay, you will get the value of 1. So this means any number multiplied, okay, by its reciprocal will equal 1. All right, now that's an important concept that we're dealing with. So to solve two-step and one-step problems, you really only ever need to use the inverse property of addition, know what a reciprocal is, and use the inverse property of multiplication, okay? So here we go. Let's go ahead and just do some practice, all right, with these properties very quickly. So the first thing we're going to do is, given the following numbers, what number completes the inverse property of addition? Because in one-step and two-step problems, the odds are that we're going to have to do this, especially in two-step. In two-step problems, you're not going to be able to avoid this, okay? So here we go. So 5 plus, right, so I did this example above, is -5 is its opposite, will equal 0. Good. Okay, so now let's take a look at B. It starts out as -3. Okay, so we want to take the opposite or find the opposite of the number that is currently there. Okay, so it's not always going to be this minus, all right? The opposite of a negative is a positive. So the opposite of that is +3. That gets me 0. So notice we've just been using what we call integers, all right? What we haven't used yet are things called rational numbers. And rational numbers are just things that are written as fractions. So 1/5, what is the opposite of 1/5? It is -1/5. So even if I have fractions, okay, it holds true for that. Moving on to D, 2.4, okay, the opposite of 2.4 is just -2.4. So it works for decimal form. E, mixed number form. +3.5. The opposite of +3.5 is -3.5. Okay, so what you should be noticing here when doing this is just the signs are opposites. Okay, so F, I have -2/3, which means I need a +2/3. Okay, so if I take -2/3 and add to it 2/3, I will get 0. All right, so that's practice with the inverse property of addition. Now let's do some practice with reciprocals, okay? This is the part we have to talk about, all right? So the formula above is really just saying to you, okay, that what you are simply going to do is you're going to look at every single expression as a rational, all right? So if it is rational, all you are going to simply do is you're going to take it and you are going to flip it. So 5, written as a rational number, is 5 over 1. So what's important here is every integer can be written over 1, All right. So, or the opposite of that is you just can use the formula for integers straightforward, which means I take 1 and I divide it by 5. All right. Now, what matters for b is that now it's already in rational form, and when it's in rational form, the only thing you need to do here for a multiplication for this thing to equal 1 is you just flip, okay, the fraction around. So a reciprocal literally is just switching numerator and denominator. That's all it is, all right? So C, you have 4/5. What's it going to be? Take a guess really quick. Okay, so here we go. It is 5. Okay, it is 5/4. Then we go to 6/7. So 6/7. Again, take a guess before I give you the answer. And it's 7/6. Okay, so notice all I'm doing is flipping them. So then E, -2. Now notice there's nothing there's no fraction here. So if there's no fraction, it's just that number, okay, underneath 1. So it's just -1/2. Then D, it says -2/5. So again, all we do is flip the fraction. So I get -5/2. Okay, so now what's important here is we're trying to make +1, which is a very, very important concept here. So I already had one negative, which means I needed another negative, okay? So you must use two negatives to create a positive. Two negatives multiplied together make a positive number, okay? So then this last thing here is, and I'm sure that some of your teachers already talked about this, well, what about subtraction and division, okay? Well, subtraction is actually the inverse property of addition, okay? So this may seem odd, but what subtraction does, okay, is it just simply allows me to write the inverse property of addition with one, okay, less sign. So subtraction is the inverse, okay, property of addition. So when we have subtraction, a lot of times what you'll see your teacher do is they'll just write a minus sign. So this, the inverse property just lets the rest of the write to write this with one less sign, okay? So if you see 5 plus -5 equals 0, it's acceptable just to write 5 minus 5 equals 0, okay? So moving forward, the division is simply the reciprocal of multiplication, is the inverse property, okay? It's simply the inverse property, okay, of multiplication. So I'm going to simplify this because I'm running out of space there. So it's the inverse property of multiplication. So again, this may seem odd, but if you think about it, okay, instead of writing something as 4 times 1/4, okay, it's acceptable just to write it as 4/4, which is just 4 divided by 4. But just to be clear, this is not a requirement. You don't have to write it like that. And honestly, a lot of times when you start getting into higher order classes, like, or you know, your geometries or your algebra 2s or your algebra 1 classes, you are actually going to need to know and use this a lot more often than you would anything else. So knowing this is actually a lot more beneficial than when you're solving these problems, and you'll see in a moment what I'm talking about, and I'll show it all ways that I can possibly think of. So that right there is the beginning piece. These are the core pieces. So now let's take this information and let's use this in some problems. So here we go. So looking at some problems here. So first thing we need to think about is, now that we're moving into equations, we need to think about properties of equality. So any mathematical operation introduced to one side of an equation must be equally done to the other side. So let's just go through this very quickly. All right, so we're going to go through some basic formulas, things you need to understand, okay? So the addition property of equality. So if I have some value of A equal to some value of B, then if I were going to say A plus some value, okay, of C, then I must equally add that same value of C to the other side. And that's all it's saying. So basically, if I add something to one side, I must add it to the other side. Subtraction property of equality. We start off with that same A and the same B. Then instead of adding C, if I say A minus C, I must then equally do to the other side minus C. So if I subtract one thing from one side, I must subtract it to the other side. Multiplication property of equality. Again, we start off with that same A and B. So this time, instead of adding or subtracting, if I do A and I multiply it by C, okay, then I must take that B and multiply it by C. So what's very, very important here is this beginning statement, okay? This beginning statement is setting up a statement of equality. So if I have one thing equal to another thing, or if I have something equal to another, all right, then if I introduce addition or subtractions or multiplications or divisions of any type, I must equally do it to the other side. So let's just finish this off, okay? So division property of equality states that if I have some A equal to some B, then if I do, okay, A divided by some C, then I must take that B and also divide it by C. Okay, so that's just an important idea of what we've done. Okay, so let's take that information and let's just apply it very quickly. All right, so here we go, solving one-step equations. Now, I'm going to do these using the inverse property of addition and the inverse property of multiplication, and that's all I'm going to use. And then I'll show you again in the two-step equations, I'll show you how maybe your teacher might write this, okay? So anyhow, here we go. So m plus 3 equals 10. So the goal here is to isolate it so we have one of our variable. All right, so if you look at this problem currently, well, we have one m. The problem is we're adding 3 to this m. Now, we don't know what the m is, but I'm going to add 3 to it. So there's an addition sign there, okay? And so I want this thing to go away. So if I have an addition sign, I want to use the inverse property of addition, okay? So the inverse property of addition states, well, I'm adding a positive 3, so I want that positive 3 to go away, so what I'm going to simply do here, all right, is I'm going to add the opposite, okay? So I add the opposite. So if I put plus a negative 3 here, what's going to happen, all right, is that this now makes 0, so I can cross it out. But the most important thing is these properties of equality that now state, hey, you just added, okay, an opposite of 3, which you just added a negative 3. So that means I got to go to the other side and put plus that negative 3. Now, here's the deal, right? So I want to show you something, right? So we go back to this idea of subtraction. Do I really need to write plus a negative? And the answer to that is no. So what you'll see a lot of the times is your teacher will just write minus 3, and that is acceptable, okay? So what they'll do is then they'll write that down below, so we get m equals 7. And there's a one-step equation, sorted, okay? So now we look at number 4. So now it says x minus 5, okay? So really what you need to be thinking about, again, right, is that this is really x plus negative 5, all right? So this is really x plus negative 5. Well, if I want that to go away, I use the inverse property of addition. The inverse property of addition simply states you need to add the opposite. Well, if I want to add the opposite of negative 5, that means I add 5. So negative 5 plus 5 makes 0. Going back to properties of equality, what you do is you say, okay, if I add something to one side, I must add it to the other side. That's it. So we add 5. So now the question is what is negative 2 plus 5? And negative 2 plus 5 is 3. So x now equals 3. So I hope you're following along with what I did there for the addition and the subtraction, but it's literally just looking at opposites. If you're adding or subtracting, you are going to add or subtract, okay? So here we go, number 5. Number 5 says 4x. Well, you need to know that 4x stands for 4 multiplied by x. So here, okay, is where I like to use the inverse property of addition. I don't want 4 x's, I want 1x. Well, how do I turn 4 into 1? And that's where that reciprocal, okay, idea comes into play. That's why the inverse property of multiplication is so important, because if I want to turn a 4 into 1, I simply multiply by its reciprocal. So what I'm going to do is simply multiply this by 1/4. Now remember, if I multiply one side by something, I must multiply the other side by something. So I'm multiplying by 1/4. So what I now get here is, I get x, so 1x, you only need to write the x, you don't need to write the 1 in front, is equivalent to, now 18 times 1/4. So what is 18 times 1/4? Now, there's a multitude of ways that you could write this, okay, but 18 times 1/4 is just going to, I'm going to use a decimal in this case, is just 4.5. Okay, so don't worry about it. You can, if you don't know that, you can use a calculator if you want to. If you want to do practice with your numbers, 18 times 1/4 is 18 over 1 times 1 over 4. So when you multiply fractions, you multiply numerators and get you 18 over 1 times 4, which is 4, which then simplifies to, okay, what goes in the 18? That goes in the 4, which is 9 halves. And if you wanted to, you could leave it as 9 halves. It's no longer simplified. But if you wanted to convert that to a decimal, 9 halves is 4.5 as a decimal. Okay, so you could leave that answer in multitude of formats is what I was saying to you. But I just left it as a decimal for this one. Okay, so you just have to make sure you're leaving it in the form your teacher wants you to. All right, so now we're on to number 6. And number 6 says, y divided by 5 is equivalent to -4. Now, I want to point out something that's extremely, extremely important here, okay? It's 1 over 5, okay? It is just 1 over 5. So how do I get rid of 1 over 5? Well, there's a beautiful thing called that multiplying by the reciprocal, because this is 1 times y, okay, over 5. So all I simply need to do here is multiply by the reciprocal of the numbers I have. So if I flip the 5 and the 1 and multiply that side, and then I go over here and multiply by the same thing, well, 5 over 1 is just 5. So just write a 5 here, okay? So what I've got going on now is that what you should notice here is I just flipped it. That's all I'm doing. Okay, I'm multiplying by the reciprocal. So what I get here is that this side becomes 1 because 2 reciprocals multiplied together make 1, and the other side is -4 times 5, which ends up being -20. And there's my answer. So the only properties I'm currently using are going to be the addition, the inverse property of addition and the inverse property of multiplication. That's all I'm using. All right, so 2/3 times x equals 10. Again, I want to get rid of 2/3. Well, how do you take any number and turn it into 1? You multiply by its reciprocal. So go ahead and multiply by 3 halves, and then go to the other side and multiply by 3 halves. Now, x equals, okay, whatever the outcome of 10 times 3 halves is. Now, so there's a couple ways you can do this. If you want to show your work, I'll show it down below here. But this is just going to be 10 over 1 times 3 over 2, which then equals, if you want to multiply straight across, you can. You get 30 over 2, and 30 divided by 2 is just 15. So the answer is x equals 15. If your teacher allows you to use a calculator, then use the calculator. Type it right in there. 10 times 3 halves. Just make sure you type it in correctly, and you should get the answer as x equals 15. Moving on to number 8. Number 8 says r plus 3/5 equals 7/10. Now, what's important here, okay, is that who cares if it's a fraction? Is that fraction being added, subtracted to r, or is it being multiplied or divided to r? And the answer is you have an addition symbol. So if you have an addition or a subtraction symbol, you must use the inverse property of addition, which is pretty simple here. So I'm going to add, so the opposite of 3/5 is -3/5. Now again, like I said to you, you don't need to write plus a negative if you don't want to. I'm a fan of doing that. That's just me though. So if your teacher allows you to, you could just write -3/5, -3/5, all right? And what you get here is that these two make 0, and now you're looking at what is 7/10 minus 3/5. Now, I like to put these in here because I think it's important that you know how to add and subtract fractions without a calculator, all right? But if you don't, then just go grab the calculator, I guess, and do it, all right? But I'm going to show you how you do it again, just as a good refresher. So the way you add or subtract fractions is you make common denominators. So this is so we have a 10 in the denominator, and down here we have a 5. So what I need to do is turn this into equal amounts of 10. So this is some whole broken into 10 pieces. So I need to figure out what would this, something broken into 5 pieces, be if I broke it into 10 pieces. So the way you do that is pretty simple. You just ask yourself, how can I turn 5 into 10? And that's done by multiplying by 2. So you multiply top and bottom by 2 of your equation. And what you'll be left with is that, all right, just as a new problem, will be 7 over 10, just showing my work here, will be minus 6 over 10. So 7/10 minus 6/10 is 1/10. Now, okay, if that work there, all right, confused you, I would like you to understand that you should probably watch a video on adding and subtracting fractions, because it's extremely important that you know that process going forward. I know for the sense of this problem, it may not be so. You could just use a calculator and you will get 1/10. So, all right, so you get r equals 1/10. So, things I want to point out very quickly. Your answers can be negatives, Your answers can be decimals. Your answers can be fractions. Your answers can be whole numbers, okay? Your answers can be integers. Notice that x can be any real number. So what's important here is that you don't always think you're doing something wrong because you got a decimal. A lot of the times, though, what your teacher will probably do is they'll probably give you nice problems that are always going to be these whole numbers or these integers of some sort, okay? But I would like you to know that answers can be decimals and they can be fractions. All right, so let's go into these two-step problems. Let's just apply a little bit more here. All right, so I'm only going to do 4 of these. And these are going to be two-step problems. Oh, sorry, I'll do 6. All right, I'll do 6. So two-step problems, all right? So the two-step problems are going to be, we have to basically look at them, and the goal is we're going to play this game of zeros and ones. So if I'm adding or subtracting something, I want to make it a 0. If I'm multiplying or dividing something, I want to turn it into 1. So when you look at a problem, the way you do something matters, okay? Because, all right, if I turn my variable into 1 first, what you need to know is that whatever number I use for multiplication, I got to multiply every number, okay, that's a different term by that value. So let me show you this very quickly, because a lot of people question, they're like, well, why don't I just do that? I multiply this right here. Okay, why don't I just multiply this by 1/4? And the problem is because if I multiply one term by 1/4, I must multiply, even though it's on the same side, okay, I must multiply the same term. And the reason for that is that this is not just one term. This is what we call a quantity, all right? So I'm taking two numbers and I'm going to be adding them together, which makes a quantity. And when you have a quantity, you must, okay, all right, group them together. So if you have to group them together, it's not like you can just multiply the 4 by 1/4. You're going to have to multiply the 3 by 1/4. And then what happens is the other side, that 27 also. So a way to avoid all of that, okay, is to get rid of that addition or subtraction usually first. So take this 3. So I'm adding 3. How do I turn that into 0? Remember, additions or subtractions we're trying to make into zeros. So how do I make a positive 3 into a 0? Well, you say add -3, which is just -3, right? That's the power of subtraction. You don't have to write the plus, the negative. And then I write -3. So now what I get is 4m is equivalent to 27 minus 3, which is 24. Now again, there's two routes here. I can multiply by the reciprocal, which is what I'm a fan of, or you can write that multiplication of the reciprocal, as I talked about in the first page there, as simply division. Now, I know a lot of teachers will probably write this as division. I'm just not a fan of it. I'm much more a fan of learning the multiplication by a reciprocal because it's something that you'll use much more frequently in higher courses. So I'm a fan of just saying, hey, how do you turn 4 into 1? You multiply by its reciprocal, which is 1/4. So 24 times 1/4, okay, and you get m equals, so what's 24 times 1/4? And 24 times 1/4 is 6. Okay, so if you didn't like that, that's okay. I mean, it's fine. Everybody has their own thing here, okay? So what you can do, all right, when I got to this step here below, just to show this, when I got to here, and you had 4m equals 24, a lot of teachers will just say, hey, divide by 4, hey, divide by 4. And the reason they do that is because you're at the beginning and they think it's a lot easier for you to understand. 24 divided by 4 is just 6, right? So what I'm more in the business of is I'm trying to get you to understand that this is a property you're going to use the reciprocal a lot more, all right? And I get that it might be a little bit harder, a little bit more confusing at first, but once you get this reciprocal idea down, it actually makes things really easy for you, all right? So here we go, on the number 10. So again, I just like to use the inverse property of addition and the inverse property of multiplication. So here we go. Again, you see I have a division here. So I have a division, and then outside of that division, I have an addition sign. Well, I want to make this thing go 0. So here we go. So how do I make positive 6 into a 0? And the way you do that is you add the opposite. So add a -6. Well, again, I can just write that as -6. So property of equality states that if I put this -6 here, I got to put it on the other side as well, okay? So I now get this y/5 is now equivalent to 12 minus 6, and 12 minus 6 is 6. So now, one thing that I definitely want to point out is that that y has a 1 in front of it. So how do I turn 1 over 5 into 1? Well, 1 over 5 into 1 is just the idea of multiplying by this reciprocal. So multiply by the reciprocal, and the reciprocal of 1 over 5 is just 5 over 1. So when I go to the other side, multiply by 5 over 1, or you could have just written 5, because 5 over 1 is just 5. So here we go. The whole left side just becomes y, because multiplying by reciprocals is 1. So that's 1y. So 6 times 5 over 1 is 30, and then I am done. That's it. Okay, that's the answer. Number 11. Now this is where you're really going to like this idea of multiplying by reciprocals. Okay, so here we go. Number 11. It says 2/3 x minus 8 is equivalent to 4. So what I want to do here, again, I want to get rid of additions and subtractions first, all right, because of what I talked about before. So I have minus 8. Now remember, minus 8 really is the same thing as plus a negative 8. All right, and I want negative 8 to go away. So how do I make negative 8 go away? Well, I add to it. Okay, I add to it its opposite. The opposite of negative 8 is positive 8. So that's why I'm going to add 8 here. So I add 8. All right, and here we go. I now get that this is going to be 2/3 x is equivalent to 4 plus 8 is 12. So the next step that I'm going to do here, all right, is again, I got 2/3 times x. Well, I need to turn 2/3 into 1. Well, guess what? That's where the beauty of that reciprocal comes in. Just multiply them, flip it, and multiply. So flip it and multiply. So what I got going on here is x is now equivalent to, so 12 times 3 halves. So 12 times 3 halves is just going to be the good old number 18. And I get my answer is x equals 18. Okay. So on to the last one, which is number 12. Nope, we got 3 more, sorry. So on to number 12. So number 12 says 3x minus 1 is equivalent to 13. So here we go. I have, again, I want to point out to you that this is plus a negative 1. All right, so how do I get rid of a negative 1? You add its opposite, and its opposite is positive 1. So do plus 1, 13 plus 1, because it's property of equality. What you do to one side, that makes 0. This side is left with 3x is now equivalent to 13 plus 1, which is 14. Okay, and then here we go. The next step to this, okay, is going to be that I take that 3, all right, and now I'm going to do it. I'm just going to do this problem just because this is the way some of your teachers will do it, and I want you to see it. All right, so this time, and suppose they're multiplying by the reciprocal, a lot of teachers will just say, hey, divide by 3. So you can put that fraction bar in there and put divide by 3. 14 divided by 3. And this is where a lot of kids get confused with this method because they go, well, you can't divide 14 by 3. Well, guess what? You can, not evenly. All right, that's an important idea. You can, it's just not evenly. So if you can't divide evenly into something, you leave it as a fraction and simplify it, or you're going to write it as a mixed number. In this case, I'm going to write it as a mixed number so that you understand this. So 3 goes into 14 at most 4 times, and 3 times 4 is 12. So that means that this is going to be 4, all right? And that means 3 times 4 is 12, okay? So 3 times 4 equals 12. That means I have a remainder of 2, because 12 to get to 14, okay, is plus 2. So this is 4 2/3. So I'm just writing it as a mixed number. You don't have to write it as a mixed number. You could have wrote this as 4.6 with a little bar on top, a repeated bar, okay? You could have wrote this simply as 14 over 3. So I will show you that there is 3 different forms that you could write this. So 14 over 3. These are all equivalent values just in different forms. So what is important here is that you're following along with the idea, okay, that not every answer needs to be perfect. And a lot of the times in your pre-algebra class, your algebra 1 class, your teacher's going to make them nice. But you get to the higher class and all of a sudden you start getting these answers and you think you're doing something wrong, but just know, okay, that these values are legitimate answers, okay? So moving on to the last 2 examples. And the last 2 examples are ones with fractions, because I don't want you to ever think that you can avoid fractions, because they are always going to be there. So here we go. We have 7x plus 1/3 equals 21 1/3. So what I need to do here, again, is notice that I'm adding something or that I'd be subtracting something. In this case, I'm adding. If I'm adding or subtracting something, what I always want to use is the inverse property of addition. So what I need to do is I need to look at the sign of 1/3. The sign of 1/3 is positive, so what I need to do is add the negative 1/3 in. So I can write plus negative 1/3, or you can just write minus 1/3. And then I go to the other side and I go minus 1/3. So then I just simply simplify it. Well, 1/3 and minus 1/3 makes 0, and I'm left with this number of 7x is now going to be equivalent to 21 and 1/3 minus 1/3 is just good old 21. And now I'm going to go back to utilizing multiplying by the reciprocal. So in this case, I will do multiply everything by 1/7. Reciprocal of 7 is 1/7 multiplied by 1/7. All right. So, oops, sorry there. So x is now equivalent to 21 times 1/7. Now remember that that is the same thing as just dividing. So I'm really just saying to you, what is 21 divided by 7 here? And that is good old 3. So the answer here is 3. So if you don't want to write the reciprocal, right, the other way that you could do this particular problem is that you would have just went like this. You would have said, okay, if you're more of a fan of doing this, then do it this way. Divide by 7, and you'll get the same exact answer. 7 over 7 is 1, and then 21 divided by 7 is 3. So I just wanted to show that to you so that you had it, all right? So on to 14, on to the last problem in this video. So I have positive 1/6, all right? So what I need to do, okay, is I need to say, okay, I'm adding something. If I'm adding something, I want to make it into 0. So how do I get rid of positive 1/6? I get the opposite, which is negative 1/6. So add negative 1/6, or just write minus 1/6. Okay, that's what subtraction is. So then I write minus 1/6. And what I'm left with is the answer of 3/4 m is now equivalent to 15. So from here, all right, what I'm going to do is, how do I turn 3/4 into 1? Well, turn 3/4 into 1, you multiply by the reciprocal. So I'm going to multiply both sides by the reciprocal. Multiply by the reciprocal. And what I get is m is now equivalent to, sorry, so 15 times 4/3, which is going to be 20. Now, for the end of this video, you can either stop the video or whatever you want, but at this point, I am going to just show you a quick little shortcut here, all right? So the way I get 20 very quickly is I just slide this 3 over, and I'm really doing 15 divided by 3, and then I'll just simply get that answer and multiply it by 4. So 15 divided by 3 is 5 times 4, which is 20. So that's just a quick little trick that also is nice to have with when you use the multiplication inverse property. Okay, so anyhow, I hope that was helpful. I know it's probably a little bit longer of a video, but this again is a lesson video. And if you want to watch my other video that's just shorter, it's just a quick little tutorial, then please go ahead and check out my playlist.